I don't
It's my pleasure to introduce Aaron, who has been one of the, I would say, from my perspective at least, drivers and contributors to the thing he's going to talk about, to the Better Crypto Guide. Oh, that is at least what I think you're going to talk about.
Yes.
Maybe. It might be something different. And this stuff is getting back to the real life topic of Ivan's talk. This stuff is real life advice for real life systems on the real life crypto. So I'm very happy to have him here. And
thank you.
Yeah, so just Aaron, get into it.
Thanks. Can you hear me? Yep. So I'm very happy to be here at Troopers. Actually, this is a management talk here. It's a rather technical conference. So for me, this is kind of unexpected. But I tried to change the slides around a bit. So it's a bit more technical than our usual talks. And it's also the occasion that we haven't done a talk in, I think, more than 1.5 years. This is not really because there hasn't been anything happening with the project, but not a lot of people basically want to do talks. And we have been doing talks at RIPE and the IETF and different venues for a long time. So this is basically the first one where I show sorry, I'm a bit tired. The progress we made in the project over the last 3 years. So to set the scene, how did the project start out in the first place, and what is the project about? I think there was a great quote in the morning today in the keynote that our own experiences and our own ego kind of restrict us in how far we can see. And I think this is also important with the crypto world. Every time I talk to people that are very familiar with security, most of them are doing one specific thing, like binary exploitation, networking stuff. And even the networking people, most of them don't do crypto every day, right? So this talk is also going to introduce a couple of topics you might have heard about before. In 2013, as you might remember, there were these Snowden disclosures, a big Washington Times? No, New York Times article, sorry. Washington Post article about wiretapping. And a lot of people began to talk about the crypto apocalypse, or the cryptocalypse. I can't really say it. A lot of people were very worried back then. If you looked at Twitter discussions and then mailing list posts, it was mostly management people and systems engineers that didn't really know what to configure and how to configure it properly and where to start. Where do I start looking? I mean, do I just type into Google, how do I configure Apache with HTTP correctly? The first hit will probably be Stack Exchange. And there will be a post from 3 or 4 years ago. Is it still relevant? Have you looked at the code? Does it still work in the same way? We found out, the two people that started the guide, Aaron Kaplan and Adi Krigish, that there wasn't something like that around that we could just use and recommend to our upper management or any of our operations people that we have on the ground. So they started discussing, and Aaron is from the Austrian CERT, the Computer Emergency Response Team. He actually wrote to the mailing list. He's the same common name as me. If anybody wants to contribute. And at first there were a couple of people from Austrian universities, and it kind of spread out. In September and October, the project basically went public. We said we have a project name, and the name was very trivial, Better Crypto. We had a meeting with 20 people, and we couldn't come up with a better name. I'm really sorry. The draft or our guide is called Applied Crypto Hardening, which is also kind of a formal, not very cool name, but we're not that cool. So a lot of contributions started to come in. What we saw quite instantly was that a lot of people were uncomfortable with the way we were working. We were working primarily over mailing lists and discussing every review a lot. And people nowadays, they are used to forking a GitHub repo, pulling in their code, prying out something that they don't like, and then opening a pull request for opening an issue for someone to just accept the code, and they figure they're going to accept it or just going to decline. And we said we are not going this way. We're not going to go the GitHub way. We want to have very well-defined rules and policies for our guide. Sorry. So the motivation was obviously the lack for sysadmin management crypto hardening guides and no up-to-date blog posts, as already mentioned. There were a couple of crypto guides around from official institutions such as ENISA, eCrypt2, NIST, but these were made for experts. They were basically made by crypto people for crypto people. So if you were a cryptographer, you could understand them, and if you read a lot about the topic, it was easy to understand. But if you were a standard system administrator, you wouldn't read a 400-page document that is full of crazy math you have never heard about, like elliptic curve cryptography or something like that. A couple of you, I'm sure, will have heard of it. We started with applied crypto hardening. Our audience was very clear. It's for sysadmins without expert knowledge in, for example, crypto. For management people that also have a technical focus, and for decision makers in companies. I've had a lot of customers where some of the decision makers actually used to be technical people, and these people understood what they were doing. It's not very common, but it happens. Sorry. The target was explain all decisions very decisively. So in the guide and also in our Git commits, you can basically see why we ended up with some sort of decision, and you can basically see the whole discussion on the mailing list. Have an open mailing list discussion, and everything should be free and open source, under an open source license, and publicly available and auditable for everybody. So the idea was, we want to do something against the I still can't say the word, crypto apocalypse. So check for SSL, SSH, PGP crypto settings. These were the first things that came to mind. These were pretty obvious. There was a lot more stuff. So we found out there is tons of web servers people use, tons of mail servers. Some of them we have never heard about. Some of us found out that if you configure the OpenSSL conf file in a certain way, it will produce certificates that are better or worse, depending on what Stack Overflow article you have actually deployed on your production systems. So we also have this in our guide. We wrote down our experiences, and all of our recommendations are basically easy copy and pastable. Actually, they weren't when we first started out because it's a LaTeX document, and if you've ever tried to copy and paste from a PDF, it's not a lot of fun. So what we started to do is everything is in a Git repo, and all of the recommended configurations that we have in the guide, which is the largest, I'll come back to that later, the largest part of the guide, are actually in a file now. So in the Git directory, you can just go into, I think, /configurations, then web servers, Apache, and then you have the different Apache configurations depending on which headers you want to set. So why is this relevant for you? I think most of you know already. If you run networks and services, these are obvious targets. Some of you might produce code. You might produce code, but might not be a cryptographer, and might use libraries that are around. You, at some point, need to configure them, or with some libraries at least. Are you sure which ciphers to use, which key lengths? Some people are, some people aren't. Most people just took advice off of Stack Overflow, was my experience. So crypto, of course, solves a lot of problems in terms of the transport security, but it, of course, doesn't solve all of your defense in depth problems. But I think that is very clear. And our guide isn't a full guide to fixing security. Nobody has something like that. And if somebody said they would have something for that, it's snake oil, believe me. I've seen a lot of vendors say that. So who we are, it's basically, we started out with this group of mostly Austrian people. I'm also Austrian, which was just the case because the CERT team started with the guide. and they asked ATrust, which is our local certificate authority for the government, IAKs like the Crypto Institute in Austria, and a couple of other security and crypto-related people to contribute. Then at a certain point, a lot of us came to the project. I'm actually I would say I'm an engineer or a sysadmin, not really a cryptographer. These people are, some of these people are cryptographers, but I'm not. And we needed review by people that did operations in the past, by people that did code reviews in the past, that deploy production code, of course, and by people that have a strong understanding of the math behind the problem. And over the time, we actually got all of that pretty well. So the content so far, it's a rough overview. It's just the index. The largest part is actually the recommendations and practical settings, because that contains basically all of our settings for the different web mail servers or whatever have you. So we have a disclaimer that we are just trying to achieve proper security, but we might fail. We're just people. The methods we have used in the project, we basically, all of our crypto recommendations are based on the eCrypt2 guide or ENISTA guides. So we didn't want to choose our own key lengths or something like that. We wanted to have something that was backed up by an institution or a public body of a lot of cryptographers and a lot of math people that looked at it. And I think it was a very, very good decision, because at first some people suggested some settings that turned out to be very wrong in later stages, but we didn't deploy them. We used guides that were around, and the eCrypt2 guide is very good, I think. What we also did was adding a small chapter written for operations people sorry, on the theory of cryptography. So how does a key exchange work? What is a cipher string in general? I will also go over this, not a key exchange, but the cipher string. I wrote a very short chapter on elliptic curve cryptography. Just back then, not a lot of people were reading about this, and I think like how Diffie-Hellman key exchange or how RSA works is something that some of the sysadmins still have like in the back of their heads, right? They have read the Wikipedia page at some point. But elliptic curve cryptography, it's like if you're a mathematician, you have heard about it, and if you do a lot of crypto-related stuff, then you have heard about it as well. But if you're just the run-of-the-mill sysadmin, you probably haven't. I don't really understand how it works. So we wrote a short introduction and some further links what good literature on the topic is, if you really want to go into it. We have a short chapter on random number generators and the key lengths we use, which are also based on the theory, which is basically other crypto guides from the European Union, ENISTA, and the like. We have a general overview of the cipher suites we use in all of our configurations. I will go over them in a minute. And then the large part of the project is recommendations and practical settings. We also have a pretty good appendix with links in there, with tools, a lot of TLS and SSL testing tools, web testing tools. If you have suggestions for that, please add as much as you can. We have public review. Every commit usually gets discussed. If you commit, if you open a pull request on GitHub, it will usually get, depending on how big the pull request is, audited in a couple of days to a couple of weeks, because we usually want to have more than one person looking at it. Our recommendations, if they are something that changes something that is crypto-related, like a cipher suite, they need to have references and why they are introducing a change. I'm not sure why Wikipedia is in there. They should have proper references from a former speaker, sorry. Every commit, of course, gets logs, and we do reviews of them. I've actually done that. So if you want to look into the project right now and have a laptop on your lap, you can actually do that. That's our Git repo. It's read-only. You will see all of the configurations there. So our general workflow is we discuss changes first on the mailing list. Usually somebody writes up an email thread and says, hey, I want to change this. Usually it's people that either didn't really understand why they want to change something, or it was in the very beginning of the document where we just didn't have the chapters of the document yet, and people are contributing stuff. Nowadays, people are mostly contributing new server daemons and updated version of the server daemons. So some of the server daemons change their behavior, how they interpret, for example, Cypher Suite or different settings in configuration files. Yeah, and be ready for discussion, of course, because we always have a lot of discussion with a lot of very enthusiastic people about like crypto deployments. So in the beginning, we usually had like threads with 60 or 70 messages for each change, which is too much for a project. So what do we provide? We basically provide a common cipher string for all of these services where we have configurations for, and template configurations for all of these with different, sometimes with different configurations. Like for example, in a web server, you would have HSDS with or without, and different vhost configurations. Yeah, crypto background testing tools. So far we have for web servers Apache, Nginx, IIS, Lighty. I think somebody also wanted to, oh, sorry. I think that's it right now. Nginx, yeah. For mail, we have Dovecot, Cyrus, Postfix, Exim, so pretty much the standard open source mails daemons for IMAP, SMTP, and POP. Databases right now, we have MySQL, Oracle, Postgres, and DB2. I think IBM guy did the DB2 stuff. I wouldn't watch for it because I have no idea how DB2 works. VPN, OpenVPN, IPsec, Checkpoint, and a couple of other SSL VPN-based, SSL software-based solutions like OpenVPN. For proxies, we so far have Pound and Squid. We have a short chapter on GNU-PG and configurations in there, especially for older versions of GNU-PG. SSH. I think with current SSH, packets on Linux distributions, you're well off. You don't really need our guide. They have changed a lot over the last couple of years, and they're providing very good defaults. So if you use that, that's perfectly fine. But for older versions, like if you use CentOS 6, you should really look at our guide. We have Java in there, a section that's currently work in progress about Dane, and a lot of code snippets. So just to recap how Cypher Suite works, because we recently did a study at one of the companies I work at. So they took 30 technical engineers, technical students from the university, and tried to make them install an Apache web server on a standard Ubuntu box and see if they could do it in an hour, or was it 30 minutes, something like that. So out of 30, nobody managed. Is it correct? It's like out of 30, right? Okay. Which is kind of embarrassing, but that's also our experience. So that's why we started with the guide. I mean, for me, the first time I set up a proper HTTPS service, that has been years already, but I needed to look up a lot of configuration information. I actually read source code to figure out how this works and what the different parts are. So these are split into the key exchange method, the signing method, the actual cipher you're using, either with a message authentication code or here in an AAD mode, which is an authenticated encryption, authenticated cipher itself. This would be, for example, this standardized IANA TLS parameter, TLS ECDHE for elliptic curve, Diffie-Hellman ephemeral with RSA and in AES. Something to note here, the IANA standardized parameters have only been around for a couple of years, and we have SSL since Netscape times. So pretty much every implementation of different TLS stacks has their own way to define a cipher string or a cipher suite. And specific to OpenSSL, depending on the branch you're using, so either 0198 or 101, they interpret the cipher string differently. The cipher string looks exactly the same. Actually, it also changed a bit, but they interpret it in a different way. And that's, of course, the same thing with GNU TLS, which is also a TLS stack for Linux. But they're actually using something that looks very much like the IANA cipher suite. Microsoft also does that. So just to recap on perfect forward secrecy, I think a lot of you already know that, but why do we need that? Like a three-letter agency records all of our encrypted traffic. Somebody, they get access to the key by whatever means, and then the three-letter agency can, of course, decrypt all of the traffic. If you use ephemeral session keys, you're just throwing away the session key every time. And if it's a derived key, and if you try to decrypt something that has been negotiated in an ephemeral way, that just won't work. You can't decrypt traffic in the past. So on the key lengths, as I said, there's a nice website that compares all of them. Somebody set that up. It's a nice JavaScript interface for the different crypto guides by different states like the US, Russia, Europe, and what they're recommending. We basically went with the eCrypt2 guide. So RSA should be above 3,000 something bits for ECC 256 and SHA-2 and AES 128. There's been a lot of discussion about AES, and I really hate that because people get really fixated on small issues that are not really the problem. There's been no real break of AES or no real very important attack on the cipher in the, never actually, but people find some reference on Wikipedia that tells them there's a reduced round attack. So we can't use AES 128. Have you ever tried to implement this attack? A reduced round attack doesn't mean it works with your OpenSSL implementation, but yeah. So there has been a lot of discussion about ciphers, and especially if you should prefer other ciphers that are not NIST standardized, for example, Camellia and stuff like that. We went with AES, and we also threw out Camellia a few days ago. One of our guys is from Belgium, and he actually just wrote Vincent Reimann if you should use AES 256 or 128, and this was the answer Vincent Reimann gave us. So on the choice between AES 256 and 128, I would never consider using AES 256, just like I don't wear a helmet when I sit inside my car, which was a nice response. We actually have that in our guide, I think. There are some theoretical attacks, but we are not too worried about them. So we talked to a couple of cryptographers about these attacks, and they basically said they are just academic. So what does this look in a configuration file? What is a cipher suite? Is the protocol version? Yeah, of course, the protocol just defines the TLS or SSL version you're actually using. And down there is this whole big string of different key exchange methods, different ciphers you could take, and different message authentication codes. And all of this needs to work somehow on different versions, on different distributions, and on different branches. So in general, what we wanted to do from pretty much the beginning was to disable SSL version 2. It's outright broken, and it has been for ages. We also wanted to disable SSL version 3. There has been a lot of pushback at first about this because of legacy users, for example, XP, and a lot of mobile. In 2013, a lot of people were using old versions of Android. There's also the problem that in the third world, actually in China and in Africa, you have a huge deployment of Windows XP machines because these people just use our old hardware. We throw it away. It ends up in Ghana, and they just take it and use it, which is awesome, but they don't have updated systems. So yeah, we actually got some statistics about it from Google people. It was interesting. We also wanted to disable the RC4 cipher from pretty much the beginning because back then, when we started out, this was the time when some of the RC4 attacks started to appear. They were relevant for HTTPS traffic, not really relevant for other traffic back then. But we said we want to disable it, and a couple of months later, I think half a year later, the IETF actually standardized that RC4 shouldn't be used in any protocols anymore. We also wanted to disable all export suites, which is also very, very obvious. Export ciphers are from the early 90s. This also kills the freak attack, for example, SSL version 3, Beast and Pool, but I'll come back to that. So TLS version 1 or better. What I have to say about TLS version 1, TLS version 1 is pretty much very similar to SSL version 3. There's some changes in it, but it's not much better. There's like the vulnerabilities they found in SSL version 3 are mostly fixed, but the standard looks almost exactly the same. They just exchanged SSL for TLS, and nobody knows why. we wanted to disable TLS compression. Back then, the crime attack was also coming out. Implement HSTS for HTTP traffic, OCSP stapling for web servers and stuff like that. Come back to that. We have two variants of our Cypher switch, which is a problem, I think. I think we should reduce it to one, but everybody just uses the B version. So the difference is the variant A of a Cypher string is for people that have like a local deployment where they can influence the clients a lot, so the client deployment. But when you have a central managed infrastructure and you can just say, I want this version of the operating system with this crypto library, you don't have any problems. You can actually say, oh, just use this Cypher on all of our infrastructure, don't negotiate a lot, and it will work. But most of the people are using are hosting public services, so they went for our variant B, which is our more modest version that actually works on the internet. The other one does as well, but it's made for the local network, and our guide says so. It has a few weaker ciphers and key exchange methods, but it has broad client support. And back then, as I said, there was still a lot of XP deployment. An example again is Apache. So this is how it looks in a configuration file. The honor cipher order on is also very, very important because otherwise the client could suggest cipher suites. But that's basically how it looks, and it's large blobs of cipher strings that we actually verified. I wrote scripts to verify that across a lot of different OpenSSL versions. Our cipher strings only work at OpenSSL. We didn't port them to GNU TLS, Crypto API, and what have you, because we don't have enough contributors right now. So how do you test that? I think that's obvious for you. So OpenSSL client is the worst way to do it because you never remember the command line parameters correctly. But most of us have scripts for that. You can use it to debug. It also has a debug flag and a message flag that will show you a bit more output. Another very nice tool is SSL scan. It's, if I remember correctly, a lot of bash scripts hacked together, but it works quite well. Everybody has seen that before. It's the SSL Labs website that basically everyone uses to find out if their web server is configured the right way or not. This was our report from a year ago, and it's still the same. So yeah, it's an excellent tool actually because it also has a lot of information about client deployment and issues with different versions of clients and different libraries in Java or in different Android mobile clients. So it's very interesting to see which kind of protocols would work with your Cypher suite. If you wanted to do your own, you could just do that, test it on SSL Labs, and see what would work and what won't. And that's an excellent tool. I don't know of any open source tool that will do it in this manner and with so much expertise. They have so much data about like Java libraries, different Internet Explorer versions, Safari, and all of that stuff, even Tor. But of course, that's like their selling point also. It's a commercial, they are selling commercial products. A very good tool, I've also used it for scientific research, is SSLize. It's a fully featured SSL scanner. The guy that wrote it wrote actual OpenSSL Python wrapper for it to access lower level OpenSSL features that weren't exposed via the normal OpenSSL API in Python. You can do a lot of stuff with that. It basically supports tests for all of the TLS bugs that have been out there and published in the last couple of years. The tool is very good, but like 2 years ago, the guy stopped maintaining it, and then he picked up again, I think this December. So the tool now has a lot of new contributions. A lot of people that sent pull requests now got accepted also by me. So that's when I found out that the guy is working on it again. And then I saw his Twitter message, I'm working on this again. If you want to talk to me, I'm at Congress, which is nice. Sorry. It also does start TLS testing, XMPP, Java testing. It tests for server name indication in web servers, for virtual hosting, HSDS, all of that stuff. So that's how it looks. It basically gives you a large output of all of the details of your configured cipher string. It also will give you some information about this about a certificate trust store. The SSLIS tool actually uses the Mozilla local trust store just to verify if the certificates as seen would work with a Mozilla browser. So what are the attacks that we have mitigated in the past with our guide? Some of the good things we basically contributed was defense in depth for some of the people that have deployed web services via our guide. And I think a lot of the people that used our guide are pretty happy with what they've chosen, because as you can see, we mitigated quite a few attacks. So the crime attack requires TLS compression. It's an Oracle. From the very beginning of our project, we always turned off TLS compression and application level layer compression. So for example, the breach attack, which builds on crime, is an attack on HTTP compression instead of TLS compression. So our recommendation was always, so if you turn off compression on the transport level, you also should do it on the application level, because there will be another attack. New breach attacks are going to be released at Black Hat Asia, by the way. Some improvements of that. Poodle is you basically are required to use SSL version 3 if you're not some certain vendor that was vulnerable for Poodle in TLS, which is amazing. Yeah, but like the first one was a big appliance that always comes up on the TLS mailing list. But then, yeah, a lot of people figured out that it was like 4 or 5 vendors that had the same issue in quite a few variations. We explicitly forbid SSL version 3. This kills the Poodle attack. We can't really do anything about bad appliances, just don't buy them. For Logjam, that has been released about a year ago, the man-in-the-middle attacks requires you to use Diffie-Hellman with 512 or 768-bit that you can decrypt. If you use stronger parameters, it's very unlikely that you have the computing power to do that. But for a 512, you can perfectly fine do it on Amazon in about a couple of hours. There's automated tools for that out there to actually do the attack and perform it as a man-in-the-middle attack. We have always recommended that, if possible, try to supply Diffie-Hellman parameters that are larger or equal to 1024 bits. The problem when we started out back then was a lot of the implementations didn't have any support for that. So some of us actually opened tickets and committed upstream to get support for that. I think in Apache already had a ticket open for that, but some other service, and it has. For me, it was very interesting that we had discussion on the topic very early on. I think in October of 2013. So a lot of people were very unsure how to configure this properly, which Diffie-Hellman parameters to use, the ones that your services provide or that OpenSSL provides. If you use a basically pre-generated file, should you generate your own ones? There weren't really good recommendations about it. We also mitigated Freak. That this requires export, so low security, early 90s, US ammunition law ciphers. You might remember there was this incident where Daniel Bernstein sued the US government because of that. And they actually had, at some point, had to remove this export law. We explicitly always excluded export ciphers, so for us the problem is pretty much solved. And we can't do anything about implementations. The drone attack was very recently published. It's a cross-protocol version attack that requires SSL version 2, at least. We have always recommended against enabling SSL version 2, so from the very beginning of the project, we basically said, don't use this. Some of the mail server distributions that we have supported, like especially Postfix, the distributors of the daemon and also the developers pushed heavily for SSL version 2 support. The reason was that a lot of SMTP servers negotiated SSL version 2, and if you turn it off, their fear was that you might end up with a lot of bounced messages. We actually did some research about it 7-8 months ago and found out that it isn't that bad. The paper isn't on there because it's from a different project, but I can give it to you after the talk if you're really interested in the details. About implementation-specific attacks. We can't do a lot against implementation-specific attacks. We're trying to provide good configuration guides for sysadmins and decision makers. So some of us might be engineers, some of us might be security engineers. These people will contribute to the project upstream in their own time, but it's not the focus of our project, and it can't be. We can't have a security audit team as well. But we try to provide a good config guide. We're not auditors. And of course, there have been a lot of attacks on implementations, OpenSSL, the Apple API, Microsoft, and different appliance vendors with very weird versions of some bugs, or like bugs that only on some appliance vendor work. Some of the project statistics, overall, only via Git, we had 45 contributors. I have to say that some people contributed indirectly via just mailing to the mailing list and recommending something, and then we discussed it a lot. At the end, some of us that started very early in the project then committed the changes that had write access to the Git, our own Git repository, the git-bettercrypto.org repository, which is also mirrored on GitHub. We have, as of today, 1,501 commits. Our project right now is mostly in LaTeX, so it's a lot of overhead, as you can imagine, with all of the BibTeX stuff and everything. So I didn't do any line counts, because again, remember that somebody included a BibTeX file that basically has all of the RFCs in there, so we can reference it if we ever need them. So it wouldn't make a lot of sense. I looked at the mailing list as well. We had more than 1,200 messages, I think more than 1,500 by now, over the last 2 years and 7 months now. So this is basically where you see where the project started out and where it started to become less interesting to some people, and where attacks turned up. This is usually where people start to contribute again, or get interested in the project, or change settings around in certain daemons. And this is where we see commits again. The large chunk of the project was done by a team of about 20 people in a room with remote people phoning in and via chat. And it was basically done in October to December and a bit in January of 2014, but mostly in the autumn of 2013. So pretty much after the Snowden disclosures. And yeah, of course, a lot of commits, a lot of text included. Is a 100-page document by now, including all of the appendix and all of the references to tools and everything. Always new posts to the mailing list appear if new attacks are disclosed on either implementations or general protocol bugs. Again, about the implementations, we can't really do anything. Generic protocol bugs, if you can mitigate them in some way, we always try to do that, and we are very happy to accept pull requests for that. So after John, some people found a bug in, I think, some of the postfix configurations, and they immediately sent it to us, and we accepted it, of course. We have improvements to the document right now, mainly via GitHub, not via the mailing list anymore, which is a bit of a problem for the workflow, because as I explained before, we wanted to start out with a workflow, we have a discussion before, and then basically commit stuff. So right now it works like this. If we have an important PR on GitHub that not only a few people can look at, but that needs real discussion, one of us will open a thread on the mailing list. It will get proper discussion and inline reviews of the people that have reviewed the pull request. So in GitHub you can do comments on line numbers as well. So say, this shouldn't be there. A good example for this is the mail section of our mail servers that has been changed a lot in the last 2 years. Somebody is working on rewriting the whole thing for DNS, again Dane as well. The Java section also recently changed. And some people always add their favorite tool, like some small TLS web service that they use. A bit of discussion. There is the big topic of post-quantum cryptography that some people might have heard about. So the fear is that at some certain point, we will have a quantum computer that can break some of our crypto systems that are deployed today and in real time, and that it won't be as far away as 10 to 50 years. This is a huge time span because every time I talk to physicists or cryptographers, they all tell me a different story. They all tell me something between at least 10 or 50 years, or I won't see it anymore. I have no idea. In my opinion, and I also think in general in the opinion of our project, all of the new post-quantum crypto schemes are not standardized yet in any form. We can't use them. There are implementations, but no useful implementations for us. So you won't find code for that in OpenSSL. You will find an academic implementation by some of the authors of the paper or something like that. We currently have no plans to add anything in this direction. We certainly would if there is a decisive move in general in the crypto community towards post-quantum, not in general, on working on post-quantum, but standardizing this. The Crypto Forum Research Group in the Internet Research, IRTF, Internet Research Task Force, is actually working on that right now. But IRTF basically is the research part of the IETF. So they do research, and at some point, IETF people might write a standard that makes use of their research. So that could be like 10 years away. It won't be because there's a lot of a huge part of the crypto community right now is involved in research in post-quantum cryptography. So the theoretical crypto people that actually do all of the math that I can do, they are looking at that. It's interesting to us, but we can't recommend it right now, as I said. There has been a lot of discussion about elliptic curve cryptography. So when we started out, Daniel Bernstein started with his Safe Curves project. He basically challenges the NIST and NSA curves that are everywhere in our browsers and used by most of our key exchanges for HTTPS websites right now. May they contain a backdoor? They have parameters in there that aren't disclosed, so it's not clear how they got in there. Is it a backdoor? Was there something pre-calculated? Nobody really knows. My opinion always has been that it's probably okay, but there is also now a paper from two of the people that defined the area of elliptic curve cryptography that came out in 2013. They basically told a very similar story. They don't really see a backdoor in there. And when I talk with people that audit a lot of crypto code and with some of the Google people that have these ECC implementations running on all of their web servers in production, they told me the implementations are hardened and very good. I have to believe them because they are mostly better. They mostly have more and better security engineers than our project. IETF will standardize non-NIST curves in the near future, so especially curves from Daniel Bernstein. One of them is curve 25519. There is already drafts for that in IETF. So once that happens, we will of course include it. It's already in our guide actually for SSH because SSH started to support it early on without any standard. But it will be very similar in the standard. So in the future, of course, we need, as you have seen, we need to have continued input from domain experts. So if you know a service very well, if you know an appliance or the math behind some of our recommendations very well, review our document, talk to us, and audit some of the configurations we publish, and tell us this doesn't work, or tell us it works. I have verified it. Just verifying it is a huge step for us and helps us a lot. The project is still active. There is a mailing list discussion going on, but it needs upkeep. So a lot of the people that contributed at the very beginning are not really contributing anymore. So the project upkeep and also the upkeep of trying our configurations with new packets and new versions of software daemons is a very important issue in my opinion. It should be automated. And that's exactly the next slide. My idea was like 2 years ago, if somebody finds time, it would be really, really awesome to automate all of our testing with, for example, Jenkins, Vagrant, Puppet, if you want to do a deployment as well, and to have some testing between different TLS stacks, different server daemon versions, and different operating system versions. So different, for example, Red Hat versions or your favorite fork of Debian. From there, you could also go to automatically deploying stuff with Puppet, Chef, or Ansible and producing deployment files for that. It's just an idea. We haven't really looked into that, but could be possible. From the very beginning, basically, we were looking for somebody that would do us a very nice JavaScript web interface for choosing your perfect configuration for your server. So you basically go to the website and say, I have this version of the operating system, and I want to configure Apache, and it just outputs you a nice copy and pastable snippet that already contains maybe some predefined variables you set, like the host names and vhost. The status quo, in my opinion, distro and package security with regard to crypto settings has improved significantly, especially since the Snowden revelations. There's a lot of people, I see it in Debian and also in Red Hat, there's a lot of people really looking into that. There's, from the Red Hat security people, they are working on a baseline configuration for the whole Red Hat system, something very similar to our approach to having a cipher string, but basically in an etc directory. They have been working on that for like 3 years now, and it's not public yet, or not deployed yet in either Fedora nor Red Hat, so I'm not sure if that will ever work, but it's a very nice idea if distributions would actually go that way. It would basically eliminate the need for our document. Yeah, distro teams are very good. There's tons of legacy systems that are deployed with really bad crypto. I nowadays do a lot of internet scans, and the stuff I see is very bad. There is scanning research not only by us, but also by Rapid7, the University of Michigan, and if you look at their papers, some of them are also involved with the recent TLS attacks. Yeah, legacy systems are really a problem. The IETF works on a lot of protocol and security related improvements. We don't really know the time to market. With some of the drafts have been published in a very fast manner. For example, the disabling RC4 draft I talked about in the very beginning, basically forbidding RC4 in the whole IETF and protocol standardization process. Other drafts that are very good have taken ages to get to RFC status, just because they haven't been reviewed by a lot of people in time or other bureaucratic issues. Most sysadmins are largely unfamiliar with the topic in my experience. Once I talk to sysadmins, some of them have been looking into the topics because they nowadays want to have A+ on their SSL Labs website. But they follow Stack Exchange or sometimes new and not very well researched blog posts, and usually unreviewed. We have a few sections in the document that would need some improvement in regular checking, and especially testing and automated configurations. For example, a good idea would be Apache over all of the different versions of legacy and current Linux distributions, different OpenSSL stack versions they're linked against. The more people audit, discuss, and review our project, the better the project becomes. But that's, of course, logical. If it's not spammed by crypto tinfoil heads, like I talked about before, we don't really need discussion about certain things like AES or Camellia. These are things real cryptographers should decide about, and we are basing our recommendations on guides from ENISA and similar organizations. So yeah, this is not the right platform to have this discussion, in my opinion. That's it, and I think I'm in time. I have time for questions. I think there will be questions. Thank you. Thanks. was afraid that I have too much slides. Yeah.
So the first part regarding the JavaScript interface, Mozilla has actually a JavaScript interface for the Apache server.
Yeah, you mean the Mozilla...
So that might be something, and I see you forgot the testssl.sh.
Yeah, I didn't have a lot of tools in there. We have a workshop worked out as well, where we only talk about tools, and you can look it up on our Git repo if you want.
Okay.
And also in the appendix, there's a huge section only about tools and how they work and everything.
Right. Have you heard of any tool implementing a UDP-based SSL scan? Like, is my IKE, is my radius, is my whatever?
But Ike is not TLS based.
Right, but radius would be, and my IPsec connection part with all the protocol handling that does the SSL TLS crypto part. I mean, you have the configuration recommendation, but how would I go about verifying that my exposed server interface actually implements that? And same goes for OpenVPN for sure, but...
yeah, of course, but OpenVPN has a different architecture.
Right, so I would leave that out, but for Radius and an IPsec?
For IPsec, we don't really have a section about IPsec right now. If you want to contribute one, you can. I wanted to write one, and then I just didn't, because it's IPsec, and fuck that, sorry. You don't really have any clients that have proper proper Ike version support anyway. So if you have a Mac, I think now it works. But if you had a Mac like a year ago, it only supported Ike version 1 in aggressive mode, which is broken. And
right, but Ike version 2 is gaining traction.
Yeah,
so.
at some point.
I'm not sure if Mac should serve as an example of a standard client anyway.
Sorry, I have one, but a lot of people have.
I come back to the legacy problem.
Yeah.
Were there thoughts about liability? Because when we have something like due diligence, what is your project providing somehow, and as well as a NISA standards or something else, we could go to the vendors and say, okay, you don't fix that. This is a liability issue. And here are some very strong companies that might go in such a
We actually had this. we actually had the discussion. Do we want to have like better crypto certified software or stacks or something like that? I was against it. Some people were for it. I think it's a community project, and that's up to standards bodies and to certification bodies, not to us. And I also think that we don't have the manpower to do it right now. There are more important things. Any other questions right now?
Anything else? If not, we close the session here. Thanks again, Aaron.
1 minute.